You can use context clues. You can use context clues to figure that one out, man. I'm sorry.
Might need to go get my
Not yet. That's good. Okay, so today we're going to talk about the quotient rule. So I'm going to give you what the quotient rule is, and then I'm going to show you some examples. I'm not going to give you a proof for why the quotient rule is what it is. I will record a proof of why the quotient rule is what it is and put it on my YouTube channel, but I don't think many of you actually want to see that today because it's going to make things more confusing. So instead, I'm just going to give you the quotient rule. So let's say we have some function h of x, and h of x is equal to f of x divided by g of x. So that's where the quotient comes in, because there's division. If you want to find the derivative of h of x, so d dx of h of x, that's going to be equal to, and here's where the quotient rule comes in, f prime g minus f g prime, not bad so far, divided by g squared. That's where it gets bad.
It's just FOIL.
Kind of, yes.
Except
So,
with radicals instance.
and possibly with e to the x's, and possibly with sines and cosines. So,
So you're saying it's basically
Yeah, I'm thinking of
well, I mean, it can be foiling. I mean, okay. So let's take a look at an example from your assignment. I'm going to take this directly from your assignment. Flub and d5. I'm not going to tell you which number, dude. Come on.
Gotta find it.
Let's do. Say we have a function y is equal to. I know that one will not close. No matter what I do to this one, it won't close.
You just gotta like fit the little thing in the.
I know. I got to go outside and fix it.
No, like fit the little.
No, I know, but I
can
have to go outside
and
to fix it. Because no matter how much I spin this.
I can go and fix it while I leave it down.
No. So I'm sorry. You're going to have to deal with that little bit of glare. I apologize. There's a little bit over here. All right. So let's say y of x is equal to 2x to the third plus 2 divided by 4x to the fourth plus 3. So in this case, f of x is what's on top, and g of x is what's on bottom. You can't flip-flop these because division isn't commutative. So I'm going to say that this is f of x, and down here, this is g of x. So to make my life a little simpler, first thing I'm going to do is find out what the derivative of f of x is, so f prime, and then I'll find the derivative of g of x. So the derivative of f of x is, just using the power rule, I get 6x squared, and then the derivative of g of x would be 16x to the third. Alright, cool. So far it's not so bad. Now, plugging this into the quotient rule up here, I'm going to do f prime times g, so 6x squared times 4x to the fourth plus 3. So 6x squared times 4x to the fourth plus 3. And then I'm going to subtract from that all of f times g prime. So this is going to be 2x to the third plus 2 times 16x to the third. And then this is all over g squared. So 4x to the fourth plus 3 quantity squared. Now, you can go further with this because it's just like it's just foiling, and then up on top you're just distributing. So if you're distributing the 6x squared to both things here, you're going to get 24x to the sixth plus 18x squared. No, the reason you can't is because there's not a 4x to the fourth in all three of these terms. There's 4x to the fourth in these two, but there isn't one here, so you can't cancel it, and it's because of that minus. It turns the top into not one term, but two terms. If I wanted to, I could separate this into two separate fractions, and then I could cancel out the 4x to the fourth, but no. Okay, so then here I'm going to do minus 32x to the sixth, and then this is going to be another minus 32x to the third, and then this is all over, when I FOIL the denominator, that turns into 16x to the eighth,
Why'd you write 32x?
Oh, because I made a mistake. This should be 6. Thank you for pointing that out. So when I FOIL the denominator, I'm going to get 16x to the 8th, and then I'm going to get a plus 9 over here. But there's a third term that's in the middle. 4 times 3 is 12, and then if I double that, I get 24. So plus 24x to the 4th. Now I can combine some like terms here. So on the numerator, my like terms are 24x to the 6th and minus 32x to the 6th. Yep, so minus 8x to the 6th. There's no x squared like term, and there's no x cubed like term, so minus 32x cubed plus 18x squared all over 16x to the 8th plus 24x to the 4th plus 9. So that's the derivative of y.
It's not that bad.
Okay, but I think, in my opinion,
It's a lot of work.
well, I didn't put any radicals in today's.
Oh.
Today's all look like this for the quotient rule. There are some product rule review questions that have radicals in them.
I still don't get radicals.
Okay,
Like, we strike notes about them.
okay. And then there's a bunch of questions about radicals, but they're not involving the quotient rule. So let's take a look at your assignment and let's go through part of it together. I know you're excited. I can see your face. So your textbook actually has yesterday's notes and today's notes and another set of notes all together in one section. So I decided to break it out into different sections, which is why we're doing worksheets. Okay, so what we did just now was number 5. So let's take a look at another one with the quotient rule, and then let's look at some of the ones with the weirdo exponents, like 7 through 12. So one more from 1 through 6. Let's do question number 4, maybe. So up on top, this is f of x. Down on bottom, this is g of x. So off to the side, I'm going to find out what f prime and g prime are. So f prime, g prime. So Christian, what's f prime? Cool. Michael, what's g prime? What's g prime? Cool. So now we're going to do f prime times g. So 8x times, in parentheses, 3x to the 4th plus 3 minus f times g prime. So 4x squared plus 4 times 12x to the 3rd all over g squared. So quantity 3x to the 4th plus 3 squared. And now I have to do some distributing, and then I have to do FOIL on the bottom. So if I distribute up here, 8 times 3 is 24, x times x to the 4th is x to what power? Cool. And 8x times 3 is, okay. And then I'm going to do minus, that's going to be 8x to the 5th. And then another minus 8x to the 3rd. Because when you multiply x to the 3rd by x to the 2nd, the exponents add to make it. Oh yeah, it is 4 times 12. Ah, thank you. So it should be 48. 48. Thank you. I saw that 1 there that I wrote as if it was part of the thingy thing. The parentheses. Okay, so bottom we got 9x to the 8th. We got plus 9 at the end. 3 times 3 is 9, times 2 is 18. So plus 18 x to the 4th. And then if you do some combining like terms, you get negative 24x to the 5th minus 48x to the 3rd plus 24x all over 9x to the 8th plus 18x to the 4th plus 9. Kind of, sort of? No, Christian? Okay. Is it the foiling, the distributing, or the derivative that gets you? Right. So there's three places that I can definitely see you having trouble with. Is it the foiling, the denominator, to get this? Okay. Is it distributing what's on the outside to the inside to get this? So the reason it's 18 is because if you're doing the middle terms, 3 times 3 is 9, x to the 4th, and you're going to have two of those. You're going to have one from doing first times last, and one from doing inside times inside. And then so 3 times 3 is 9, and then if you double that, you get 18x to the 4th. Kind of, sort of? All right, let's look at one of the harder ones. I know, the stuff from yesterday. So there's a weird radical one on question number 10, and there's a weird radical one on question number 8. Who has problems with radicals and would like to go through either one or both of those? Yeah, Reese, which one? Do you want to go through 8 or 10? 8 or 10. Or 10 or 11, sure. Which one do you want to go through? All three? 10. Okay, let's start with 10, and then we'll see where we're at. All right, so I'm going to label this as f of x, and the second part is g of x. So from there, I want to find out what f prime is and what g prime is. So f prime, if I'm using the power rule, is, I know, it's 8/3, because 4/3 times 2 is 8/3. And then x, what's 4/3 minus 1? Bless you. Yeah, positive 1/3. Cool. And now g prime is pretty easy. Yeah, I'm going to change that in just a second. So this is the same thing as 8/3 times the cube root of x, because it's x to the 1/3 power. I'm going to change that in just a second, though. So f prime g, so I'm going to do 8/3. I thought maybe this might help some of you, but I don't know. Let's see. X to the 1/3 power times 2x squared. And then we're going to do plus fg prime, 2x to the 4/3 minus 1 times 4x. So I thought maybe it might help if I left this in its fractional exponent for just a hot minute before we converted it back to being a radical. So if I'm looking at just this first part here, so I'm doing 8/3 times 2, what would that be? 16/3, 5 1/3, however you want to write it. And now if you're multiplying these two together, you're going to add the exponents. So x and 1/3 times
7.
Right, so this is x to the 7/3.
Oh, so then it's cube root x to 7.
So I thought maybe that might help you. I don't know though. Now if you're looking at the next part, you're going to do 2x to the 4/3 times 4x. So that's going to be 8. And then instead of being to the 4/3, it's going to be to the whatever 4/3 plus 1 is. 7/3. And then we're going to do minus 4x. So now these two both have the same exponent, which means they can combine because they're like terms. So 16/3, which is 5 1/3, plus 8 is 13 1/3.
40.
X to the 7/3. Okay, that was a big side. That again or Mike? Okay. You doing okay over there?
Yeah.
Okay. Are you just saying yes to get me to stop talking?
No.
Okay. Because I'm a math teacher, I'm used to that. So there you go. So I thought maybe it would help if we didn't change it back to a radical until the last step. That way you can use the properties of... This one is the product rule, not the quotient rule. 1 through 6 are the quotient rule. And I kept them relatively simple because I think the quotient rule is more difficult than the product rule. 7 through 12 are the product rule.
How do you know?
Well, are you multiplying the two things or are you dividing them?
Oh, yeah.
Yes, Michael?
Yeah, you could start with number 1, right?
I mean, sure. I'll even set up the answer key so you guys can look at it if you want to.
I don't know why they quit on this.
Okay.
Me too.
I looked at number one and you explained it and I was like, yep, nope.
The answer key doesn't jump to the answers either. It actually gives you the correct form and the answer. And that's nice. Okay, this is number one.
So what?
That's right for the.
That's for it.
So when you multiply these two together, you have to flip it. And that's right for that. And that's wrong for that. This should be plane. Or sorry, plane. You did G prime times that prime. This should be G prime times plane n, which is 5x to the fourth minus 5x squared. So in here should be 5x to the fourth minus 5x squared. Your denominator is exactly correct though. So that's good. You don't need to change your denominator at all. Up here, this turns into x to the fifth. Minus 40 to the third. Okay. You need to FOIL these two, which is 2 terms by 2 terms. So this is only part of it. There's also 20x to the third times 3, so 60x to the third, and then you're minus 40x to the third. Okay? You guys want to look at the answer? Feel free.
Wait, I don't.
Okay, I have
Oh
an
my god.
You'll be okay.
I
This thing is long.
Sure. So, which one are we looking at specifically? Okay, so 19. So, where is this horizontal? So what you're going to do is find the derivative of x squared plus 1. The one
Go
below.
to that.
2x. Set that equal to 0 because the horizontal means it has a 0 slope. So 2x equals 0. What is x? So your x value is 0. Now if you plug that back into here, and there, for x, what do you get back up for? Okay, so 0, 1 is the point where it's changing on the horizontal. Zero, so it's on 0. Okay. Is the 15. Okay. So find the equation of the line change to the graph y equals x squared plus 1 to the point p. So first you're going to find the derivative. And then you're going to substitute p in for x. Find what the slope of the line will be. You're not going to get numbers, it's going to feel really inside. 2p. If it's 2x,
Oh,
then you put p in for x, you get 2p. That's your slope of your line. Now, you're going to use pq as your point, and this is your slope. So you're going to do y minus p equals to 2p times in parentheses x minus p. And now you're going to distribute the y by itself. You're going to get a really unsatisfying answer. It's going to feel like it's wrong, but that's what it is. So this will be 2px minus 2p squared. Right, and those aren't like terms, so 2p squared and plus 2. And that's it. That's it. It feels really unsatisfying. It feels really unsatisfying. Now, for the next one, you're going to use pq, but you know the line goes this way. So you already know the slope is going to be 2p. So rather than doing this, which p and q, you're going to use 2p as your slope, and your point is 1, 7, 1, negative 7. So you're going to do y plus 7 equals 2.95. There's one. You're going to distribute. I know.
It's pretty easier though.
Good news is you only have to assign to this week, but
You're right.
so I don't need to feel bad. I'll be able to sleep just fine. Yep.
So I can find that.
So find the slope of the line change equal to line minus the square root of 1, 1. Oh, okay. So find the slope of this.
So 1.
2x, and then put
Oh,
1
2x,
on.
so 2.
And then put calculator, you can put that only huge. Right, so you hit second, I think it's more than highlighted. Make sure you highlight it if it's not highlighted. Okay, now second changes.
Reese, what you get? Check that again. Oh, wait. I got it. It'll be 2x over 16x to the fourth plus 24x squared plus 19x. 2x.
But now you're looking for
No, because the distribute the negative. 16x to the fourth plus 24x squared plus 9.
which part do you control? Okay, so f prime is 20x to the third minus 10x.
Because
G prime is
fourth
8x plus
multiply 4x squared times
So
4
you're gonna
squared
do,
with 16x to the fourth. If you add the
f
x
prime times
on,
G.
then you go 4x squared plus 3
plus 3
plus 12x squared, and then there's another 12x squared plus 4x squared.
So 5x to the fourth minus 5x squared times 8x, smaller than 4x squared plus 3 times g squared. Your denominator is 16x to the fourth, you got plus 9 at the end, 14 is plus 2 is 24, 24x to the second, so that's your denominator. Your numerator is going to be 80x to the fifth, and then minus 40x to the second, plus 60x plus 4x squared times 20x to the third, plus 60x to the third. Okay, so let's go through this. Well, hold on, let's go through it. So 4x squared plus 3, 20x to the third minus 10x. Alright, so why does it make it? Why isn't the this is f prime and this is g? Yeah, f prime goes in front. It doesn't matter. So like multiplication is community. Because it's 2 terms times 2 terms, you have to FOIL it. No. So you're doing 20x to the third minus 10x. For number 1, this is whatever you call it. You f prime 20x to the third minus 10x. 4x squared plus 6. Since you're multiplying 2 terms by 2 terms, you have to FOIL it. Oh, yeah. 1 second. So when you FOIL this, you're going to get 20x to the third times 4x squared is going to be 30. It's up here in the book, and then plus, and then other one, but yeah, it's 2 terms times 2 terms, so you have to, now on the second one, you can just distribute 8x to both ends of the side. Okay, so first things first.
Oh, no, this is still the first part.
I know. Outside is outside. Oh, that should be outside. Inside and inside. So then this is really 80 and then I don't know what the other part can be, but you just have, the other part you just have to distribute it back with things inside.
Yeah, that doesn't
Because
isn't it just minus 20
because you have 2 terms times 2 terms, you have to FOIL it.
But
It's okay, you can ask questions.
still be 24 x to the fourth.
So minus
On what?
40x to the fifth.
When you
Yeah.
boil that out, should they be boiled to the fourth power?
Yeah.
What should?
Yeah, that's right. So minus 40x to the fourth.
Yeah,
Or 40x to the
It
fifth.
should be 16x to the fourth on the bottom.
16 x to the fourth or 24 x to the fourth.
So then this is next one.
40
X to the second.
No.
Yes.
I guess I
3 doesn't have an X on it.
Yeah.
See, I could be making
So it
mistakes.
stays the same. You don't add the exponents when you add the numbers.
I have forgot that.
You only add the exponents when you multiply.
No, I made a mistake. Where did I make this?
So, when you boil it to the fourth, it's square and fourth split.
16x to the fourth
When you go fourth square,
times 3.
would be 12x squared.
Yes.
3 times 4x squared. So this should be 6 squared is 9. 5 below the square plus below the square.
No, 24x squared. Because you're not changing the exponents. When you add them, you only add the numbers in front, not the exponents. When you multiply, you add the exponent.
That's what your numerator is. Okay, because it's plus 40x to the third and plus 20x to the third.
I think I ended up screwing up somewhere there, that's,
Okay.
yeah.
Do you still have questions?
Yeah.
Okay, 1 second.
Come across those two.
No, because there's not one in every term.
So that's just
Well, you can combine your, yeah, this would be okay, your final answer. Mm-hmm.
I actually have a question when I was gone on Monday.
Okay.
On 21.
Okay, so for 21, what's the derivative of y equals x squared? For left, what do you say?
2x.
Okay. So 2x means that the slope is 2 over 1, meaning it rises 2 and runs 1.
Yeah.
So then you graph that out.
keep getting this true for the
We're looking for the measure of that angle right there.
Okay.
So this is opposite to adjacent. So which can we sine cosine to?
Adjacent tangent.
So if you do
So inverse tangent of
2,
2.
make sure your calculator's in degrees. And that'll give you the measure of that angle.
I'll just keep going.
And so same thing here, you'll do the derivative,
Inverse
just
tangent
divide it
of
over
3.
And then for C is asking for the difference between the two angles. So just do angle B minus angle A. Okay. Okay. Okay, so So
16 times 3.
38.
48.
Or 48, yeah. What number is that?
2.
Because if everything has a derivative, you can do that, but if you didn't do that, that's fine. If every term has a common factor, you can do that, otherwise, don't. It has to be in every term.